Okay, good morning. Last class, I had asked you to do the biodegradation, few types of them. Okay, each group one method. So there are enzyme degradation, microbial assimilation, and also the backbone reaction, right? Okay, so today we will discuss on the class activity. Then after that, I will conclude those methods. Okay, can we have the group representative to discuss each of the topic, each of the method? Enzyme degradation, which group? Which group? Enzyme degradation? The girls, right? So what is about enzymatic degradation? We focus on the plastic, organic waste for plastic. Okay, can you discuss a bit? What is this about?
So it's by and this is quite obviously used very method in the form of the potential of something else.
Okay, for the mechanism, how it goes?
Turn off and then use it. And there is this some for the most implemented and then used by microbial cells and the other soft to manage how that's. This is the one.
Okay. Adsorption or absorption? D. AD. Okay, how do you understand the adsorption and hydrolysis over here? Surface.
And that not be into.
Okay, so the enzyme stick on the surface, adsorb on the surface of the plastic, and they react on the surface, adsorption, AD. Okay, so then after the process, it will release the products, CO2, H2O. This one?
The enzyme absorption on the polymer surface and hydroxylation or hydrolysis of the bond two step of the enzymatic degradation. Microorganisms from very standing and some animal secretaries as the origin of the enzyme that present something. Waste petrol has been converted to higher value products such as biodegradable polymers by mineralization or polymerized food polymer monomers for recycling using microbial and enzymatic degradation.
Okay. So for the biodegradation method, enzyme degradation is the first step. Enzyme, a microbe attached to the surface, then it releases the enzyme for the reaction. Okay, that is the first step. Then we move to this one, microbial assimilation. Okay, thank you, the girls group. Now we move to the microbial assimilation. Which group is this? Okay.
Yeah.
So microbial assimilation is for the term assimilation is basically like metabolism of the microorganism where it consumes the nutrient to convert it into energies, which is actually good. And then the mechanism need to be called because next slide we have the picture.
Okay, here I want to I want to confirm adsorption or absorption.
For this one should be absorption.
AB. AB, right?
Because it's the one with
Okay, so this one should be absorption because it absorbs.
absorption is a oh, it's a
Yeah, it absorbs the nutrient. Absorption, because it absorbs the nutrient into the cell. If adsorb, just on surface. Okay. Okay.
So maybe we shall to the next slide. Basically, you will my first on surface. For yeah.
For the this one, the first and second is the trigger step. The actual step for estimation is the third one, which is the estimation, where the small enough particle already go through the trigger step will be absorbed into the membrane of the cell itself. So the microbes will use the cell for generation of energy for their growth, and like even they produce the waste excreted outside the cell. So the process between the cell itself is the excitation.
Correct. Okay, so girls, focus. This microbial assimilation is when the microbe absorb the nutrients. Okay, this is when this is when the enzyme degradation microbe attach on the plastic surface, then it will form the biofilm. Okay, so enzyme release, they react, then the nutrient will be absorbed by the microbe. Okay, and then react. After that, only produce the CO2 and H2O, the products. Okay, microbe absorb the nutrients. Okay, this part is the backbone change. Okay, this part is the backbone change, which is explained by the next group. Is it? Okay, backbone chain. Wait, I put in slideshow.
It is it's a bone breaking process. That is occur when the is exposed to high temperature. Yeah, and this process also known as the chem reason.
Transition.
Okay. It could occur at the chain end or at a random position. If it occur at the chain end, then monomer will be formed. And the process can be known as unzipping, depropagation, or enzyme depolymerization. On the other hand, if the bond breaking process is occur at a random position, then monomer or polymer will be formed.
So basically, the UV radiation and oxygen is the initiation factor for the polymer to undergo fragmentation or oxidation. And then the backbone of the polymer would be clean and generate the polymers and monomers. Like it will be clean and then become smaller particles. And the picture is the types of backbone for different polymers.
Okay.
So for the target compound, the backbone chain breakage between the bigger polymer like such as the saturated alkane backbone polymer polymerase backbone. So the common example of alkane backbone are such as the PE polyethylene, PP polyethylene, and polystyrene. So the picture shows the end atomic up the backbone chain is the very long chain, and then the B are the tendon tubes.
Okay, thank you. So this part is on the mechanism. The reaction occur when the microbe attach on the surface, then it breaks the plastic. So that one is the degradation part. It breaks the plastic using the enzyme. So it breaks based on the backbone chain breakage, where it can occur, as mentioned over here, it can occur chain end or random position. Okay, at chain end or random position. As long as it is on the backbone. Backbone is the main straight chain. Okay. So then monomers are formed. It will form into smaller chain, smaller particles, so that the microbes can degrade, can consume for their nutrients. Okay, this is an example of the backbone chain breakage from amide. Then goes using UV radiation. Okay, it break into two at the carbonyl and the amine group. So from here, proceed, they will convert into CO. So perhaps after this have further reaction which will convert into CO2, the final product. Okay. Yes, correct. So the plastics will be degraded by the enzyme, okay, which produced by the microbe into smaller monomer. So this one can be considered as their nutrients. Microbe will consume as their nutrients, then release as the final products into CO2 and H2O. Okay, this is for example on the backbone chain breakage. Okay, different plastic, they will have different compound, organic compound. Okay, here it already showed the backbone, the main straight chain. Okay, the B atoms are pendant groups here means the branches. Okay, the branches. Okay, now this one I found a very good journal which it explain in detail on the plastic degradation by microbes. Okay, so they have come out with a very good abstract, graphical abstract, where you have here from the plastic waste, polymer, biodegrade by the microbes. Okay, so from the microbes over here, this is, let's see clearly. Later I share this one with you. Okay, this is when the microbe absorb, okay, attached to the surface of the plastic. Okay, this is the microbe. Then it degrades the plastic, consume this as their nutrients. Okay, then it will release the CO2 and H2O and the energy. Okay, this is the summary of the process, the plastic degradation, biodegradation by the microbes, okay, depolymerizes, the chain scission process, okay, the bond breaking, it convert into monomers and metabolized by the microbe. So it will absorb and consume, released as the biomass. Biomass here, it means the waste of the microbes. Okay. So this is a more detailed process where it shows the defragmentation of the polymers, okay, into macromer, then into monomer, absorbed by the microbes, produce CO2, H2O, and the energy. ATP is the energy. Okay. Then consumed by the fungi. Produced by the fungi. This specialization, will you take biochemical? You will take microbiology. Okay.
I think in
Microbiology. Is it?
one, yeah.
One of the elective. So you should take or not?
Where expert writing.
Yeah, I just at the level of the biology pathway.
Okay. If you take microbiology, then you will learn in detail on this part. The TCA cycle. Only on the microbes. How they react. How they, what are the energy release? What are the enzyme? Very biology. If you take biochemical engineering, also first part we learn about the microbe, then only the process. Okay, I will share with you these articles. This is a very good articles. I will put in CN later on. I just share with you here. Okay. This is a review paper, a sustainable approach. So they compile all together. So this subtopic relates with our topic, where we have gone through last time the type of degradable plastic, okay, types of degradation, and then the mechanism, okay, enzymatic mechanism, empty. Okay, so it explained in detail. Here, this is the bigger picture. Microbe attached to the plastic, then it degrades the hydrocarbons of the plastic into monomers, absorbed by the microbe and consumed as nutrient. Okay. Released as CO2 and H2O and other metabolic products. The ATP.
This as enzyme on the surface.
Sorry?
Is it the microorganism is releasing the enzyme to decompose plastic?
Correct.
So it's not like bacteria is attached to it and then consume more like what should I say? It's not attaching it and then start breaking. It will break the enzyme first, then start attaching. It's something.
It will attach on the surface first in order to react. Attach, then release the enzyme, then degrade the plastic into monomers. Then that monomers will be absorbed by the microbe as nutrient. Okay, like you eat food now, you have to put food inside your mouth first. Then only an enzyme come out, right? To process the food, to degrade. Then it shows you the flow chart, how it goes. Okay, this is the disintegration process with the assistance of light, stress, and heat. Either aerobic or anaerobic, it will produce CO2 and biomass. Okay, but anaerobic, it will produce some methane gas. Okay, I will share with you this journal, no worries. Okay, perhaps you might want to read out this one, characterization of plastic biodegradation and factors affecting biodegradation. Okay, there are a few factors such as functional groups, okay, complexity in the structure, whether it is linear or branch. As in your organic, linear and branch will have different properties. Okay, bond types, amide, ester bonds, there are different properties as well. Composition of the base of molecules. Okay, the polymer's nature and physical appearance, whether it is in pellet, films, or powder. Films, flat surface. Powder, it will have larger surface area. In your opinion, films and powder, which one will degrade faster? Powder and film. Powder. Why do you say powder? Surface area, more surface area. So it will, reaction rate will be faster and it will degrade faster. Okay, the density and its molecular weight, the morphology, amorphous and crystalline region. This is also affected. And also whether there are the toughness. Soft degrade faster than soft degrade faster than those that are hard and tough ones. Okay. Type of the microbes. These are a few types of microbes that can degrade the plastic. Memorize only one is enough. one, at least one name lah. One name. Let's Pseudomonas is common one. Pseudomonas, right? Huh? No issue lah. No issue.
Which one is that?
Huh?
Which one is the common one?
Pseudomonas. Sorry? No lah. Perhaps if I ask you, give one example of the process. So you might want to include type of the bacteria. Doesn't matter. As long as familiar lah with the term.
Yes. Yeah, that's my point.
It doesn't matter because we won't focus on the microbiology part so much. Okay. Okay, so this is the process. Biodegradation of the PE. Yes, as I showed earlier, where the microbes will undergo the transition process. Turn into macromer, then into monomer. then consume, produce the byproduct. TCA cycle itself in biochemical engineering, if you take this one, will be like one subtopic.
What?
Yeah. Okay. I will share with you this journals, no worries. Okay, so far, as I mentioned to you, your midterm will be covered until chapter 3, right? So I will cover until this topic only, plastic waste. We have one more subtopic, which is the petroleum hydrocarbon. That one I will push in for next class. That one will be our last lecture lah, next class, the petroleum hydrocarbon part. Okay, so today I will just go through back what are the exercises that we had done, which might be asked in your midterm. Okay, let me see. Chapter 1, we had gone through the types of bioremediation, right? Let me, let me open the slide. Sure. This one. Okay, this one, you just look, do some revision on this part, where this one you should be familiar with the ex situ, in situ method, the intrinsic, engineer, how to explain them and how to illustrate them. This table, this is the summarize of some of the types for in situ and ex situ. Okay, in situ, last time we had discussed on the biostimulation, bioaugmentation, okay, biocomposting, right? And then the ex situ, biopiles, bioreactor is a simple bioreactor, right? So land farming. For example, like biopiling over here. So you should know what is the definition, and then the mechanism, and the illustration of it. How is the illustration of the method? Huh? Illustration, yes. Because biopiling, yeah, biosparging, bioventing is different method. So I want to see how you can understand and try to illustrate it. Bioreactor is common one. Okay. Okay, this one in chapter 1. Chapter 2. The recalcitrant methods. Basically, you will need to know as as the exercise, what is the recalcitrant molecules and how it can be treated. Fungus, enzyme, and how is the technique. Again, this technique is referring to chapter 1. Right. Like for example, define recalcitrant molecules and give one example. And then let's say you give one example of chlorinated pesticide, hydrocarbon. Then I might ask what is the application of the recalcitrant molecules mentioned in the above. Let's say you mentioned in the previous question, you mentioned example chlorinated hydrocarbon pesticide. So I might ask what is the application of that molecules? Pesticide lah. Application used in plantation for the pesticide, right? And then how to treat that molecules, that recalcitrant molecules. What are the bioremediation techniques that is suitable? Okay, or this one I can ask perhaps I give case study. Problems caused by the detergents. So how can you solve the detergents molecules? Let's say in the wastewater. So you should propose suitable bioremediation technique. Okay. So the recalcitrant, we have isoalkane, where different location of the branch will have different level of susceptibility, resistivity, right? And then we have also the recalcitrant, the detergents. Hydrocarbon derivatives, where you will have halogens on it and aromatic on it. Okay, pesticides and lignin. Lignin as in its natural, natural structure. If lignin, sodium lignin sulfonate will be easier to degrade. Okay, here as mentioned, sodium lignin sulfonate are relatively more biodegradable than the native lignin. So lignin, native lignin is recalcitrant molecules. But if it converted into sodium lignin sulfonate, it will be easier to degrade. Okay, so if to degrade the native lignin, what you require to degrade the lignin? You need the specific enzyme, right? The lignocellulosic enzyme. Okay, so that one is chapter 2. You just do some revision back on your class exercise. Then chapter 3 would be, there are 2 parts: enzyme degradation, enzymatic degradation. Again, this one relates to the lignocellulosic waste, the lignin one. Okay, this is what I meant just now, to degrade the native lignin. So you need lignin modifying enzyme. Lignin peroxidase, LIP. Okay, no need to worry on this mechanism. I will not ask this kind of question. Okay, we are not learning biology. Okay, we are engineers, not biologists. From this activity, you just need to identify what are the target compound that this enzyme will be reacting. Okay. Lignin, of course, LIP, of course, it will focus on the lignin, native lignin. Hemicellulose on hemicellulase on the hemicellulose, right? Lactase on what? Okay, go through back. Plastic waste, as we learned just now, the summarized mechanism. This one, this one. Once you understand this figure, then it should be okay already. Okay, let me check on the CLO again on what are the covered. Okay, CLO2, CLO1, it asks, you should be able to explain the principle of bioremediation in treatment of pollutants and the cleanup of chemical contaminated site. So this one, the types of the bioremediation technique, in situ, ex situ. In situ, what are the methods? In ex situ, what are the methods? Okay, and how the mechanism and the illustration. CLO2, analyze the environmental and microbiological problems arising from the recalcitrant molecules. So I might ask, what is the definition of the recalcitrant? What are the applications and the problems that they can impact the environment? Okay, and then how to solve it. SLO3, identify the bioremediation technology for organic, up to organic only. So this one is the one just now, the plastic waste. And what, another one? Enzymatic degradation. Chapter 3, part 1, part 2. Okay, I will not cover part 3 in for your midterm. Part 3 perhaps in an exam. Okay. Any more questions? So we are left with part 3. Will be on our last class. Then on next week will be your midterm. Next week, Dr. Lai will take over. I might do one revision class before the final exam for my part. Okay. Any more questions? Clear? Huh? Midterm.
Yeah.
Tuesday. Tuesday. 14. 12:30 to 2. Okay, 12:30 to 2. Not during class hour. 12:30 to 2. I combine with fuel combustion. Okay, any more questions? I don't plan to proceed with part 3 yet. Okay. Clear? Okay, so that's all for today's class. We'll see on Thursday.